One of these pictures is not like the others. Not quite sure how obvious it is, although I've probably used it on the thumbnail, so you'll probably be able to guess. It's also got a button on the side. I've always liked the idea of a digital photo frame, but I really don't like LCD picture frames because they're too bright and they need some sort of intelligent way to power on and off. So my ideal picture frame is going to be an e-ink frame where it just runs on batteries, got no cables, and it just uses the ambient light. They've always been quite small. I actually kind of lied just then. There's two images on this wall that are e-ink frames, so this one as well, but this is quite small. Larger e-ink frames are coming out in colour. The pre-made ones that I've seen advertised on Instagram, none of them had quite the feature set that I wanted. So when this e-ink frame came out on Pimoroni, I thought I'd take the opportunity to have a little project and build my own. So this is the brains of the operation. I'll do a sort of brief overview and then probably go around the components again, explaining what each one does in detail. This is the frame itself. It's 13-inch colour e-ink screen from Pimori, and it has pin-out, or rather pin-ins, for a standard Pi. And the idea is that the Pi is too power hungry to run it directly off battery. So this is an Arduino which can sleep properly and takes very little power and switches the power on and off. The Arduino can only measure time properly up to about 8 seconds. So this is a real-time clock module, which then wakes up the Pi after however long you want, 24 hours I've got it set to. And then the Arduino switches on the power to the Pi, and then the Pi can refresh the picture frame and do its work. And then the Pi shuts down. When the Pi shuts down, it sends a signal to the Arduino to turn the power off. So to go through it in detail, the Arduino is a Pro Mini, which is important because it doesn't have the USB chip on it, which takes a lot of power. When I first heard that, it kind of scared me a bit, but it's actually one of those things that just works. So this is the programming module. This one's got a USB micro, and then the easiest way to attach it is you just get a breadboard, stick this in the breadboard, and then attach the breadboard to the Arduino, and then obviously attach the programming module by USB to the computer. And it's one of those things that just works. I haven't had any sort of problems with that. For the battery, I was originally going to power this using old vape batteries, but I decided not to for two reasons. First one being safety. I use e-ink batteries to power some radio control planes, which I think in that circumstance the kind of risk ratio is fine, because when you're using them, you're outdoors, they're always visible, and when you're recharging them, it's quite easy to monitor. But in the case of a picture frame on the wall, when it's always going to be powered on and it's in a confined space, I just thought that was a bit too risky. This is a 15-25C. I believe what that means is that this battery can discharge itself in 1/15th to 1/25th of an hour, i.e. it can supply a lot of power. Because another problem that I was having with the vape batteries, I think, is they weren't able to provide enough power. Even when I put 4 in parallel, I was still getting what I think are brownouts when the screen was updating, and nothing I did really solved that. Now it might have been the step up power supply that I was using, but I'm not really sure, but I wanted to change it anyway. So this here is the step down power supply to 5 volts. The Arduino is 3 volt, and this here is a 3 volt regulator. If I was going to do this again, I probably wouldn't bother with this regulator. What I did was I took the regulator off the Arduino along with the power LED to save a bit of power. The LED had an absolutely massive impact. I think it was like 150 milliamps. Taking off the regulator, it reduced the power consumption by about 1/3, which sounds like quite a lot. But actually, in real terms, I think it was only like 5, 6, 7 microamps. I know I'm using power incorrectly there. Please don't at me. I've had enough of that on Stack Exchange. So this brings us to these MOSFETs. The Arduino itself isn't powerful enough to switch the power directly. So you need some sort of electronic switch, which is what these two MOSFETs do. The reason why I've got two of them is because I wanted to switch the positive rail. The positive rail is at roughly 8 volts and the Arduino is at 3 volts. So because the Arduino voltage is that much lower than the positive rail, you can't use a MOSFET to switch that differential. So this MOSFET here is switching the negative rail to this MOSFET here, which is switching the positive rail. This is a P channel and an N channel MOSFET. I think this MOSFET here is way over what, because I thought that I was going to be using this MOSFET to switch all the power. What else have we got here? So various resistors. So I think this resistor here is a voltage divider, which is fed into the Arduino for measuring the voltage. So when the frame updates, the Pi is getting the image from my local server, and as that, it passes the voltage back to the server. And then if the voltage goes below, I think I've got it set to like 6.5 volts, then it'll send me an email to remind me to charge the battery. We've also got this switch here, which bypasses the Arduino, and to switch the power always on or off. I thought this was actually going to be really important for troubleshooting, debugging, but actually I've really barely used it, because when you switch power on to the Arduino, it defaults into an on state. And I've actually found it much harder to get the Pi to shut the power off rather than vice versa of having the power switch on. Kind of brings me to what was probably the most tricky bit of this whole thing, or most frustrating to troubleshoot, and that's these things are all communicating via something called I2C. So this cable here coming off the Pi is the I2C lines, and when I first envisaged this, I was thinking that the Arduino was going to communicate with the clock using I2C, and then the Pi and the Arduino were going to communicate with each other using I2C for the voltage and the shutdown command, that sort of thing. But it turns out that although in theory I2C can use multiple servers and hosts on the same line, in practice the Arduino and the Pi don't have the hardware to do that. So unless you can be absolutely certain with the timing, you have to really only have one server, one I2C server and multiple clients. So I switched the Pi to doing all of the I2C server work, the hosts, which wasn't that tricky really, but that actually didn't solve all of my issues. So this here is an I2C buffer isolator, which is kind of solved some of the issues, but it still can be slightly temperamental. This here is the button that's on the side of the case. So when you press that button, it causes the frame to update. So if the circuit's already powered on, then that signal goes straight to the Arduino, and then the Pi asks the Arduino whether the button's been pushed or not. If the circuit's powered off, then this triggers the Arduino to switch the power on, and then the update happens automatically. So this button here does the same thing, it's just in parallel for where the button on the side of the frame is not attached. This button here is a bit superfluous, but this was my first attempt at a power meter. So if you press that, so at the moment you can see it's got, oh, is it green there? Wasn't showing green before, was it? So yeah, that's a power meter in case you want to just check it quickly like that with it and taking it off the wall. I also used button A here on the frame just to stop the Pi from powering down. So if the Pi is on, once it's updated the picture on the frame, it waits for 40 seconds. If you press button A, then it won't shut down. And if you press the other button, it'll immediately refresh the screen. The power usage is very, very small. I haven't recharged this battery yet, I don't think, since I've been using it properly. It only goes down like a couple of 100 millivolts every 24 hours or so. As for the screen itself, just put this back on here. It's not the greatest picture, and the two that I've had on here have been the best images on here. So if I turn this over. So when I press the button on the side, you'll see the light on the Arduino turn on, which represents that the power is on. You probably can't see it, but underneath here there's a flash. You can see that. Can you see the green flashing light of the Pi? So this will take about 30 seconds for the Pi to boot up and change the screen. When I first did this project, I was using a Pi Zero, the original one, and because I thought that the important bit was the low power usage. However, what I've come to realise is it's actually frustrating that the original Pi Zero took like 2.5 minutes to boot and change this, update the picture. And obviously, although it's using lower power sort of, you know, per second or whatever, when it's on for 4 times longer, I don't know overall which is better power usage, but I got frustrated at how long it was taking. Yeah, this picture looks particularly nice, this one. I guess it's because of the colours, but a lot of the pictures don't look that great, to be honest. So if we flip this over, you can see that LED is now flashing, and that means that the Pi is shutting down, and the Arduino is waiting for 10 seconds to turn the power off. So when this light stops flashing, it will turn the power off. While recording this video, I noticed that the colours weren't looking as good as they had previously. So what I've done is I've removed the acrylic panel from this frame, and the colours look a lot better. And there's actually a really nice sort of matte finish on this this frame. So if the screen, so you can see there that it's a lot less reflective, and the colours look a lot better. This frame is just a bog standard box frame from IKEA. The thing that makes these really suitable to this is that they come in several parts so that you can configure them as you want, and including this, can you see that? This spacer, which obviously gives you the space for the internals of this project. You can see here that I've cut the spacer to make way for the button, and I've done the same with the back, if that's going to get in focus there. This one just happened to have in my office where I keep all my framing stuff. Quite like the colour. Found this matching button. It's quite smart. The only thing I don't like about these frames is these bits of metal that you have to fold every time you want to take it in and out. I don't think I've ever had one break on me, but I'm assuming that one day they're going to break out of fatigue from the constant bending. As I mentioned before, the 2 pictures I've been showing are the best ones for this. So normally I have a whole massive stack of photos which are served randomly. They're the photos on Amazon Photos that I've marked as favourites. My server does a little bit of processing on them before it presents them. Not very much. Pictures that are in portrait, it crops them to a square and then blurs out the sides. I don't know what the term for that is, but there is a term for that. As for sort of future changes to this, I was thinking about doing some facial detection. For example, with the portrait photos, I could centre the faces, but the facial detection actually seemed really bad in the Python libraries that I tried, which I was quite surprised about. And B, the processing just didn't seem worth the outcome, because actually centering the portrait photos seemed to do the job. The other thing is that PCBWay contacted me out of the blue. They must have come across the GitHub repo and said that they'd be happy to sponsor me. And what they meant by that was that I could get some free PCBs from them, which I'd kind of be interested in doing, but to be honest with you, I'm not sure I can be bothered, because it would mean properly doing the PC, designing the PCB, which this is working at the moment. It would be nice, but I just can't be bothered really, to be honest. In conclusion, would I recommend doing this? I think probably not. I think at the moment, colour e-ink screens are really incredibly expensive for what you get, and the quality is just not quite there yet. It looks like this, the I2C line has got stuck, I think. So press that button. If you think about the amount of money that you're spending on the screen and compare it to the number of photos that you could print out. And then there's the problem with digital photo frames is always getting the pictures onto the frame. The best digital photo frame that we've got is actually an Amazon Echo screen. And the reason why that's good is because I back up all my photos to Amazon anyway. So we have a constantly revolving selection of photos from this day on past years. And I think that's a really good way of doing it. What inevitably happens with most photo screens is that people just can't be bothered to add more photos to them. I got a photo frame for my in-laws, and it's quite an easy interface. You can upload them remotely from your phone, and we just sort of forget to do it, really. Yeah, it looks like this I2C line is hung again. So what happens when it hangs is that the Pi's shut down, but the Arduino hasn't registered the signals shut down. This jumper here, which I haven't mentioned before, this is actually just a jumper on one of the power rails. And I originally put it in so that I could measure the current, but actually it's been really handy just for resetting something like this happens. So if I put that jumper back on, the Pi should now boot up and it should automatically update the screen. I had previous problems with the I2C lines not even resetting when you remove the power, and sometimes I'd have to leave it for like an hour or something, I guess, for all of the capacitors to discharge. But that doesn't seem to be happening recently. One thing is, it's surprising how noisy this is. Just going to put the microphone next to it. It's not noisy enough that it'll really bother you, but it is surprising. So this is a portrait shot, and you can see here, so it's a square crop, and then the sides are blurred here and here. I think it's quite effective.